Hello guys, in this video we are going to see how machine learning concepts has to be applied to solve a problem. So what is the topic I have taken for today's session is the number of people and who are the people who survived in a Titanic. Actually, to solve this problem, to solve any problem, we need input information, right? So that's called data. I got several data from the internet and I also attached the link for the data in the description section. So in order to predict how many people or who are the people who survived in Titanic, we know Titanic is a great mystery, and to predict the people who survived in Titanic is going to be a mystery. But machine learning brought the solution for it. So I have generated a code to predict the people who survived the Titanic. In order to work with machine learning using Python, I have selected the Jupyter Notebook. Okay, so what is a Jupyter Notebook? And Jupyter Notebook is an interactive console to work with web-based information or to solve machine learning problems using Python. It is an user-friendly website, online platform to work with Python. So I'll directly go into the code. Okay, I have already created the notebook and I'll show you and explain the code one by one. In order to understand this, you no need to know everything about Python and everything about machine learning. Just an introduction to Python, some data science and data cleaning process, and some concepts of machine learning. If you're not well versed with it, and I'll be explaining you in this video. So okay, wait, I'll check with my internet connection. Yeah, we are ready. So actually, what is the main concept we are going to see in this is we are going to predict the people who survived in a Titanic crash. Okay, so I'll explain the code line by line. So what is a pandas? A pandas is an excellent tool to work with data frame, that is the data with multiple rows and columns. If you have a single cell of data, that is an array, you can work with Python easily. But if you have a huge amount of data, it's a better solution to go with pandas. And I'll explain everything in detail in the upcoming sessions. Okay, so what is Numpy? Numpy is numeric Python. It has everything to do with numerical analysis in Python. And matplotlib. What is a matplotlib? In order to work with multiple data, you need to understand the data, right? In order to understand, you need, instead of having a data in a row wise or column wise manner, if it is in a graph, a bar graph, or a what to say, a histogram, it will be easy for us to interpret the data. So that we are using matplotlib. And seaborn is similar thing to as it's a section of matplotlib. And we want to say about seaborn is when you have a categorical data, it will be very helpful to use it. And first we are importing all the libraries needed for it. In order to train, machine learning is all about training a model and testing a model. So in order to train and test a model, we need data. We can't create separate data for everything. So I am using the same data and I'm splitting the data into a training set and a testing set. And here I'm going to use a model called logistic regression, that is the dependency of the output on various inputs, that is many dependent variables, and we're going to have many independent variables. According to that, we are going to have one dependent variable. So first we are importing our data. Okay, I'm running the first cell, it's no problem, nothing error comes in it. Next I am reading the data. I'm having this it as a CSV file. CSV file refers to comma separated values. I am reading the value of training data into Titanic data. And describe is a function in Numpy library. It gives the number of data, the mean, the standard deviation, the minimum, what 25% of the values are this one, and 50% and 75% values, and max of the value. So everything will be given in it. So we no need to do it line by run the data line by line. Instead of running it line by line, we can give kernel restart and run all. Actually it runs all cells. So to explain, I am running it one by one for you guys. Okay, so this is the function of describe function. So first, in order to know what the data contains, so I have said you why I have imported matplotlib. Okay, for that reason I'm just seeing the data. So how many of people survived? plt.figure, I am keeping the matplotlib.pyplot as plt. So I'm using that object plt.figure. I'm just giving the figure size, and this is all simple Python code. And Titanic data, that's a, so I'm nothing doing. I'm just counting the number of people survived or not. I'm just plotting it as a bar graph. So 0 means people who don't survive and this is survive. So I'm just plotting the survival percentage and I'm checking if I have to work with the data, then I need to find there should be no missing data, because the data which we get won't be a proper data. It contains many missing values and null values. So I'm checking first, is there any null values in my data? So okay, so is null dot any, this function gives you all the null missing values and null values. Okay, yeah, okay, it gives whether it contains any missing values or null values. And I'm checking the age column, the fare column, sorry, the cabin column and embarked column. So first, in order to, we need what this embarked and these columns describe. So everything will be given in the data set and you don't need to worry about it. You can see the data set, you can understand, I'll show you later. Okay, so it contains several null values. So I want to check how many null values are there. So I'm just giving how is now means how many null values are present, and sum means it gives the count of the null values. So there are 177 age missing values, that is null values, and 687 in cabin and 2 in embark. Okay, then I am plotting a histogram. This is a histogram graph. Depending upon the age, number of people served or number of people available on these ages. So number of people, so 20 almost 50 people, see, almost 50 people available in the range between 0 to 10-year-old, that is kids, and 50 to 75 people are available, so around 125 people are available between age 20 and 30. In the similar way, I'm just visualizing my data, that's it, nothing to worry about it. I'm just visualizing my data. Okay, so I'm head gives the number of top, that is the top 5 data. Inside head, if you're going to specify 10, and then it nothing but it shows you the first 10 data. Okay, so see what are the columns: passenger ID, survived, passenger class, you got name, you got sex, they whether they are male or female, you got age, you got CBSP means number of siblings for them, Parch means number of son or daughter, their family members. Okay, this is brother or sister, this is son or daughter. Okay, this is their ticket ID and this is the fare, and this is the cabin, whether which cabin they are present. This is impact from where they started their journey from. In dataset they've given Southampton, Cambridge, Hurricane, so nothing to worry about it. And I'm just seeing number of people survived on basis of, see here I'm seeing number of people survived. Okay, the totally around 500 people survived, 540 50 people survived, and number of people did not survive. So on basis of gender, how many males survived and how many females survived, I have plotted. And plotting is similar to the same graph. See, since I have a categorical data, I am using sns.count plot. SNS stands for seaborn. Here I am using SNS. You can use anything as you wish. Here seaborn.count plot, it gives, Hue gives according to which category you are going to plot the data for survival. For passenger class, so there are first class, second class and third class passengers in our data. So for first class, second class and third class, number of people survived and number of people did not survive, all the things are given for us. Okay, okay, this is on data. I'm just running it again for you. Since there is no error, it's not going to be any problem. So as I said, head gives the top values of the data. Similarly, tail gives the bottom values of the data, and you can work on it. To visualize these all things, we are doing just to visualize the data. These all things are survival on basis. Okay, so see, this is just I'm plotting the age histogram to check the number of people between these ages. Okay, nothing more. Okay, now we have visualized the data, that is we got number of people survived. See, all the categories data gives us some information. We cannot simply omit some column or rows. Okay, now as we seen that our number of missing data, we got missing data in 3 columns, that is age, cabin and embarked. and in age we got 177 missing columns. In cabin we got 687, and in embark we got two missing data. So there are six in 891 data, we got 687 missing. We can fill this data, but filling this huge number of missing data will cause us some error, that is it will cause a great deviation in the data. So we are just dropping that row, that is Titanic data, the data frame dot drop cabin axis equal to 1, in place equal to true. In place equal to true means we are going to make changes on that data frame, the original data frame. So we are given in place into, you can give in place equal to true, or you can define Titanic data equals, you can give it also like this, and you can take in place equal to true. You can delete that, nothing going to affect the thing, both the things are just the one and thing, you have to understand it. Okay, no problem with it. Now we have dropped the cabin column. Okay, now we have 177 missing in age. You can fill it, or I'm just leaving that missing rows completely. Suppose if I have the passenger ID, see, if passenger ID 2 has some missing in, I'm saying okay, I don't want to work with it, I'm just leaving. So if there is any null value, I'm saying to drop it completely. And now I'm checking, is there any null value, and 0 0 0 0, it says that we don't have any null values in any columns. Now we have cleaned our data to work with it. So now we have to see, we got sex, passenger class, everything, male or female, passenger class 1 to 3. So get dummies is a great function in pandas to work with the data. Get dummies gives separate, that is if there is male it gives 1, if it is female it gives 0, that is it separates according to their category. Okay, get, it's a completely separates. I'm defining it in a variable sex, and I'm just creating a dummy row, we can say it as okay, like a dummy row. And similarly for a P class, that is a passenger class, I am creating a dummy row, and embark we are creating a dummy row. Since Southampton, Quarlington and 3 regions, where they started their journey, if they started in Southampton, then Southampton will be 1. If they started in C, then C it will be 1. Okay, just running it. Okay, fine, no error. Okay, so concat is one of the ways to join the data frames. Here I am joining 3 data frames, axis equal to 1, that is I am joining it as a column wise, not a row wise. Since I want to join it as column, additional columns, I am given as axis equal to 1. If I need to do it as a row wise, I would have given axis equal to 0, or if you take it defaultly it will be axis equal to 0. So I am specifying axis equal to 1. Instead of concat, you can also use a merge function, which is also a great efficient code, but concat is fine, you can use it, no problem. And see, now for this sex and embark and P class, for this we have created dummy columns, so we don't want these columns hereafter. For us, this sex column or everything we don't want hereafter. So I'm just going to drop it. I'm going to drop passenger ID, P class, name, ticket, embark, sex, because I'm not going to predict anything with name. Name is just a name, we're just going to call him by his name, that's it. So it's not going to affect anything in our code, anything in our prediction. So we are now applying logistic regression model. In order to apply logistic regression model, first we have to separate here survived. First we have to train the data, and then with another set of data we have to test accuracy of our model. So first in order to we have to train, we need to take our questions one side and answer one side. Here survived will be our dependent variable, so I am keeping it is in y, that is Titanic data dot survived I have kept in y, and x the Titanic data, that is the Titanic data I don't want. See, where they started their journey is also not an important thing in, so I am dropping the 3 rows. And see, the male and female we have created a dummy columns. See, if we can keep only one column, because they are complementary to each other. If they are not going to be male, it's a female. If it's going to be a female, it's not going to be a male. So not a problem. So I'm just dropping those things, and I'm creating a thing and saving it as in y. So this is the thing we are going to work with. Okay, uh, just an error, small error. Okay, CQ not found in access. Yeah, see, I did not run this, so that's why the error comes. Since it is an online platform, once ever we have closing and opening it again, we should run it from first, or else it creates an error. See, now no error. So what the X data contains, I'm just seeing. See, it contains only numerical values so that we could apply logistic regression model in a simple manner. If it contains large number and different kinds of data, it will be a pretty messy process for us. So I'm doing it. Now I'm seeing x dot shape dot 0 means it just gives number of rows, y dot shape of 0 it gives number of rows. Just I'm checking whether all the data present for the input and the output. Okay, so X train, X test, Y train, Y test. That is, on survival we are splitting into training data test and testing data set. As I said, from the we are importing a train test split X comma Y. From this there we are separating training data and testing data, and test size is equal to 0.2. That is, for testing data take only 20% of data, other 80% keep for training. That is, make your model to learn. Random state is equal to 42 is not an it not necessary to give, but what are the data you have taken for training, you should know that, right? So that we have mentioning a random state is 42. You can give 20, you can give 30, you can give 125, anything, it depends on your wish. You can give any number as you wish. It's just what are the data which have been taken for training, you should know that. Okay, now I'm specifying model as logistic regression. Okay, then model dot fit. Yeah, now I'm fitting my model as logistic regression. So I'm giving training X train and Y train. So for this input, this will be the output. My model learns from those data. Okay, so now I'm predicting with testing data. Prediction, I have given model as kept model as logistic regression dot predict X test. So for this testing data, what will be my output? Okay, this is my output. So I want to know whether I have predicted correctly or not. For that, from sklearn, that is scikit-learn, it is a good thing, good form for confusion matrix or for higher range problems. We have several functions in sklearn. Okay, from sklearn dot metrics we are importing accuracy score. So it accuracy score nothing but how well our predicted output and the original output fits. So I am just importing the accuracy model, accuracy score, and I'm just checking it. 80.4 percentage. It is really a great thing. In order to achieve this, I have worked out with several logics and I took logistic regression because 80.42 percentage is true. That is, the predicted value is 80 point, that is around, if in 100 values we are predicting 80 values exactly right. Okay, that's the great thing in it. So that I took logistic regression for the solution. Okay, then I have the unseen data. My model still now has not seen this data. That is a new data. This is where I have to predict. Okay, now see, this is the testing data, and testing data CSV file I have imported test.head. We are seeing the first five values. In order to give this data into our model, we need to have the same format which we have trained the data. So I am seeing, see, in x.head we have age, siblings, patch, fair and female, and 1 to 3. These are the columns. If it is going to be in the same number of columns and same kind of data, my model is going to predict. So for the similar way, I have to change passenger class, sex and cabin, embarked. I have to drop all the columns and work with it. That's what I'm going to do now. See, the same thing, I'm just cleaning the data, for cleaning my testing data in order to understand for you guys. I have done it separate steps. Python is idiomatic, pandorable Python. You can do anything in Python, right? So you can do it in a single line. For understanding purposes, I'm just doing in multiple steps, and you can do it in a single line, or when you are doing the training data itself, you can do for testing data also. Okay, it's nothing wrong in that. To understand, we are doing it separately, but when you go for higher ranges, you can do it in the same class, same area, right? Okay, yeah, Okay, now I'm checking, is there any null data in my clean test data. See, I got some null data in age and fair. So age, how I'm going to fill here, you can't drop in testing data as it is, because you need answers for that questions. Their id numbers, you need answers. So I'm going to just fill these values from the mean. That is, if I have 10 members of age 18 to 25, I'm just going to take their mean and I'm going to fill it for the value. So that's what I'm exactly doing here. I'm just filling the data with the mean value of the Titanic data age. Okay, so I'm just filling it, and similar way I'm doing it also for fair, and I'm just now checking, is there any null data. Now my column comes and there is no null data, that's why it returns false. Okay, yes, now the final data is here. Okay, after dropping all rows similar to X, we got our final data. See, it is exactly the same as the previous data, the how from which our model learned. Okay, now the final prediction is model.predict, similar way, nothing, but we are giving this new data. See, running, our model predicts it, but it's zero array of zero ones. It's pretty tough to understand, right? So see, and for a user it's not user friendly. So I'm just creating a submission file. It is a data frame with column name, one column name as passenger id and other column as whether they survived or not. Okay, test of passenger id gives the passenger id from the test data, and final prediction, this array gives the values whether they survived or not. And I am completely having it as a clean final set of data, guys, for you. Then I'm submission file, I'm converting it again into a CSV file, so that for sharing it will be more useful, and I'm converting it into a CSV file. See, you can just check here our CSV file. We have saved it as submission.csv. Yeah, it's here, submission.csv. Yeah, see, this is the index 0 1 2 3, all our index. So passenger id 892 did not survive, 893 did not survive, but 899 he survived, 903 he survived. So this model is 80.42% accurate. And this is all for today's session, and thank you guys for watching, and keep supporting. Don't forget to, if you have any doubts, don't feel hesitate to ask in comment section below, and I'm ready to answer you guys. And thank you.